Aiden, what does this curve look like? It's probably a loop. It's symmetric, vertically or horizontally. Okay. It'll work. Okay, do you agree with this graph? All right, so we need to find the area in between the loops. Okay. We want this right here. What was number 17? The inner loop. Okay, so let's talk about the difference between what I'm asking. So first, we need to figure out where the loop starts and stops. The pole. So let's set R equal to 0. Well, that means the sine of theta is -1/2. Where does that happen? Okay, so if we were finding the area of just the inner loop, we would take our integral from 7 pi over 6 to 11 pi over 6, or we could go from 7 pi over 6 to 3 pi over 2 and double it. That would probably be my preference. For the inner one. Because that would be this right here. Okay. Now we want that orange shaded part. So I want us to think about this is where we start drawing our curve. Like this is our coordinate when theta is 0. And we draw it like this. So if I'm going to use symmetry to help me with this area, because I think we should, I mean, let's make our lives a little bit easier. Where could we start finding the area? I think pi over 2 and then ending at 3 pi over 2 would be a good idea. Like this half. Yeah. Okay. Now. Okay, now I am going to take a step back though. 3 pi over 2 is probably not what we want, because where does our loop begin? How about 7 pi over 6? Isn't that what we just found right here? Right? Yes.
I don't really see that there.
That's where we hit the pole. So that's where the loop starts. And then 11 pi over 6 is when we're back at the pole. So that's where the loop stops. Okay. Now, okay. When we find polar area, we like take these like itty bitty mini slices and find their area, right? So if we start finding pi over 2 and then we rotate, like this is the area that we're finding. Oh, what are we gonna have to do? Dang it. Do you notice how I colored through that inner loop? Okay, so what we are going to need to do is we can take the integral from pi over 2 to 7 pi over 6. Then we would, of the area, then we would have to subtract out the loop that we just colored, 7 pi over 6 to 3 pi over 2. But that's only half of what we've been doing. So we would need to double it. Yes, the 2's and 1/2 will cancel. I'm writing it though because I don't want you to forget that there is that 1/2 out there for when you do just like a normal area that you're not doubling. I don't want you to forget that.
Can you just do that?
Yes, you could. No. Well, if you went from 0 to 2 pi, you would have to subtract the loop out twice. Because once you get to 7 pi over 6, well, now you're going to start coloring the loop, and then let me. Okay. Yeah, look, just hold on. Okay, so I'm gonna start. Here's my 0. Okay, here's my 0. She wants to know going from 0 to 2 pi. So if I go from 0 to 7 pi over 6, then I go 7 pi over 6 to 11 pi over 6, and then 11 pi over 6 to 2 pi. So notice how, oh, dang it, you can't really see it, but I colored over this twice. Okay.
You go from 7 pi to 6 to 11 pi over 6, it only colors the blue.
Yes.
How?
Because 7 pi over 6 and 11 pi over 6 are our zeros. And since the loop like is at the pole, this is where the loop starts and stops.
How is always going to be for every loop.
For any loop, your zeros are where they start and stop. Yes.
You do it once.
I'm not understanding what Dane's question is.
So like, you go back to the picture. It's like when you color this part, you like included the loop in this in the same one. Right?
So when I draw my pi piece at pi over 2, it's going to color over the loop because the loop is
So
there.
when you do this, like from this angle to here, it doesn't color the loop in this too.
I did, but I'm only talking about going from pi over 2 to 7 pi over 6. That was because we are going to use symmetry. Now, if I started coloring over here, then yes, do you see this, Dane? Do you see this? When I started coloring over here, it's going to color that.
But then you said at one point, like it's only the loop though.
like line, like
You get what I'm asking?
So if I were continue to find area, like if I find the area from 7 pi over 6 to 11 pi over 6, then I'm only coloring in like this little area right here.
Think about it as like you're drawing the line, it only goes to the line. You're drawing the inside, it only goes.
Just move on.
Okay, I'm just not exactly sure what,
He's asking why when you go through the loop, it just goes inside the little.
okay, here's the deal. At the very end of class, you and I are going to draw a picture and figure this out, okay? Okay,
Wait, why is this line from 7 pi over 6 and shouldn't it be 11? Or is that?
you could do 11 pi over 6 to 2 pi. It's half of the loop.
Why is it 7 pi over 6 to 3 pi over 2?
So 7 pi over 6 is where the loop begins,
Okay.
and 3 pi over 2 would be halfway through the loop.
Okay.
Here, this is 3 pi over 2, right here.
Oh, so you're doing pi over 2 is 7 pi over 6. 7 pi over 6 to 3 pi over 2?
Yeah.
A word.
What?
You know, she said
Word, okay. Okay. So now, if we wanted to actually do this by hand, okay, we're back. We would have 4 plus 16 sine theta plus 16 sine squared theta, d theta, right? Don't do that. I'm just running out of time. No, please don't. Don't write that on your test either. Whose phone is on? I mean, on loud, like not vibrate. What? Okay, can we?
That was an EX.
I know, and I'm saying, can we? I'm just not getting my words out. Integrate sine squared. We gotta change it to 1/2 minus cosine. Oh, thank you. Cosine of 2 theta over 2.
There gonna be any questions on the AP exam where we can do definite integrals with calculator?
Yeah. Okay, so 16 times 1/2 would be 8, and 8 plus 4 is 12. It has opened, so
She doesn't want us.
no, I do. I think that's a great opportunity for you.
Like, why is it only something how does that work? And in college, is that like our full time?
Yeah. So I'll take your grade from last semester and this semester.
Why is it like? Why is it only?
I don't know. They have weird.
Or is it called to this one semester?
Yes. Andre, what is your question?
Oh, if we decide not to take the AP exam, do you get refunded?
I think you get fined actually.
Get fined.
Well, you don't get your deposit back. Well, actually, you know what? They will give you your money.
I don't think they will.
Okay.
Since COVID is rampant up,
Do you agree with my antiderivative there? What? You all are ridiculous.
yeah. Because it's like 4%.
It's Wednesday. It's Wednesday. We're short on time. We've had really good discussions about pictures. You know how to evaluate an integral. Oh, we're not done. We have 2 more examples. Jeez. Yes. The next 2 examples, we are only going to set up. You're mad that we're only gonna set them up and we're not? Oh, I thought you said icky. Yeah.
I'll be there.
Okay. Does Rachel want to come?
I actually don't want Rachel.
Okay. Write this down. What does the word common mean? Okay. Okay. If I wanted to graph what I highlighted in pink, Evan, what kind of graph are we working with? What? And it's the longest portion of the cardioid is right, left, up, or down. Okay. That's good enough. All right. This one, Grace, what is the one I highlighted in blue? But which way does it open? So when I am asking for the common interior, I want to be inside both graphs at the same time. We want that, okay? Do we have symmetry? We have symmetry. So if we find this right here, could we double it? Oh, could we? So Aiden's comment. This blue area is the same as this pink area. Is Aiden correct? The only way that that is happening is because A and B are the same in both of those graphs. So we could go from 0 to pi over 2 of which graph? Nope, not either. The blue one. And we would quadruple that area. Do we understand why it's the blue graph that we're going from 0 to pi over 2 for? What did you say? You don't? Okay. So this is 0 radians, this is pi over 2, and this is pi. So the pink graph, this is 0 radians, pi over 2. So from pi over 2 to pi is where we have this pink area right here. But when we rotate from pi to pi over 2, notice how that's where we are for the blue graph.
Thank you so much.
Oops. All right, so now I have a question. What if I have the same graphs? So I guess we kind of have 3 examples to set up, but I want inside both. How do I want to say that? Okay. Yes, the interior. Okay, uncommon. The uncommon interior. If I wanted the uncommon interior, then that means I want what I'm coloring in pink right here multiplied by 4. Now, if I go from 0, are you watching me color this? If I go from 0 to pi over 2 of our pink graph, so what am I gonna have to do? Minus from 0 to pi over 2 of the blue. No. Oh, well, I suppose since we have the same limit of integration, yeah. Sorry, that was hard. It didn't need to be that harsh. Last one. Ah, stop. Did you write this one down? Okay. What do we have now? And what is that, people? Thank you. Actually wasn't too bad. So I want the common interior of these two. So first of all, do we have some symmetry? Just a little bit. Okay. So common interior would be inside the petal and the circle at the same time. So we can find this one and multiply it by. Okay. What do you think is going to be important for us to find? No. the intersection. When does 4 sine of 2 theta equal 2? Well, that would mean the sine of 2 theta equals 1/2. Well, the sine is 1/2 at pi over 6, 5 pi over 6, etc., etc., etc. So at the very least, in this first quadrant, we have intersection points at pi over 12 and 5 pi over 12. Okay. I'm going to show you. I'm going to show you this. Do you see how we color in this area here? We get to the intersection, and now we're going towards this circle. And then we get here, and now we're coloring towards the pet. See that? Okay. So we need to find this pink area, then this green area. Now, luckily, we do have symmetry, right? And the other pink. And what's going to be true about the two pinks? They're the same. So just for that one piece right there, we would need the integral from 0 to pi over 12 of our rose curve, okay, plus the integral from pi over 12 to 5 pi over 12 of the circle. And then we have to go from 5 pi over 12 to pi over 2, but that's the same as this one, so we'll just double it. The two little pink slivers are going to be the same, so we'll double it. And since I want all 4 pieces, we would have to quadruple that. And if you really wanted to get crazy and you said, I dislike that both of my limits of integration are pi over 12, you could go from pi over 12 to halfway, pi over, and double that one. Okay. And I mean, it's not a bad integral, right? You really wouldn't even have to use an integral here. It's the area of a sector. It's basically a slice of pizza. So it's a piece of a circle that we can find the area of.